If you want to try this one on your own, go ahead and pause the video, but I'm going to go through it in 3, 2, 1. So we're told that we've got two concentric circles divided into 14 regions of equal area. Well, I could find the area of just one of those regions by looking at that inner circle. I know that the area of my inner circle is going to be pi r squared, and my radius is just 2. So the area of that inner circle is 4 pi. Now that inner circle is made up of 4 congruent regions. So to find the area of just one region, I'm going to take that 4 pi and divide it by 4, which gives me just pi. So the area of any of these regions is just pi. Now if I look at the whole large circle, that entire large circle is composed of 14 of these regions. So the area of my large is going to equal 14 pi. But I can also write the area of the large circle as pi times the radius of the large circle squared. Well, the radius is composed of both the radius of my small circle, which is 2, and this segment x. So the large circle has a radius of 2 plus x, and that is going to equal 14 pi. Now I do notice that I have a common factor of pi on both sides, so let's go ahead and divide that out for ease, and then I can solve this remaining quadratic by just using square roots. So I square root both sides. Don't forget your plus minus. Let me go ahead and clean up a little bit so we can keep going. On the left, square root and squaring are inverse operations, which leaves me with just 2 plus x equals positive or negative square root of 14. Let's subtract our 2 from both sides. So x is equal to negative 2 plus or minus square root of 14. But remember, we are talking about the length of a segment here, which means we're not going to have a negative. So I'm going to omit the case where we're subtracting that square root of 14 because that'll leave us with a negative result. So our only answer here is that x is negative 2 plus rad 14. And I'm not given any units, so I'll just call this u for units. And that is it.